All right, we're back at the State Fair for part 3. I've done so many embarrassing things on our lecture today. Oh well. Oh, for Pete's sake, come on. Okay, all right. So now it's gonna get even weirder. So if you were a visitor from another planet, and you looked around at all the herbivores on this planet, what would you notice? Would you notice that there were more horses and horse-like creatures, or creatures that were more like the ruminants? Well, I'm going to argue that you would notice there's a lot more ruminants. All right. But I'm going to jump ahead here real quick, right? There's some horse-like, there's a horse, there's zebras, okay. There's, I forget what this guy's called, a Pezel something horse. There's donkeys, and that's about it, right? I threw a rabbit in there just because I was desperate, right? That's it. Those are the only horse-like species on the planet. But there's a lot of ruminants, right? There's reindeer and buffalo and the goats and all the different kind of hoof stock, elks and moose, and I can't even think of all the African hoof stock, right? There's things like camels and giraffes. And what are some of these things here? The gazelle and the kudu, right? I mean, the dick, okay? There's a lot of ruminants on this freaking planet. So what is it about ruminants that are a little more successful, let's say, than the horse? That's the question we're going to answer. The book has this term of hindgut versus foregut fermenter. So let's talk about what that means. So, but first, let's just consider this, right? So we said both the equine and the ruminant species, they can utilize the cellulose in plants. You and I cannot. Pigs kind of cannot. Ferrets, no. But these guys can. They're going to ferment the cellulose to create a very special fuel that we've never heard of before called volatile fatty acids. Okay, so they both do that. They're both going to turn that grass into volatile fatty acids. Well, they are not. The bacteria inside them are. But there's some differences, and we can look at it this way. So this I remember when I was in school, I'm like, hindgut, foregut, what does that mean? I'll explain in a moment. So the normal gastrointestinal system, that's like you and me, right? There's just the little stomach, and we don't digest cellulose. We don't ferment very much. Okay, the horse ferments in his hindgut, and what we mean is it occurs after the stomach, right? So after the stomach, we have the colon is adapted to digesting cellulose. It occurs after digestion in the stomach. In the cow, it's the opposite. All of that fermentation occurs before digestion in the stomach. So foregut, the gut is really the stomach. So foregut is before the stomach. Hindgut is after the stomach, is where this fermentation takes place. And this kind of shows it here. Here's Charlie, right? And there's his cecum and his colon, and he's producing these volatile fatty acids. That's these little arrows. That's just showing you this very unusual energy source that's being produced. But in the ruminant, some of it's occurring here, but most of it is occurring before the stomach, right? In other words, it's taking place upstream from the small intestines and the stomach. So fermentation means millions of microorganisms, bacteria, protozoa, they are helping to digest cellulose, breaking it down into into sugars. And then when they die, guess what? They travel in the foregut fermenters. They travel to the stomach and the small intestine where they are digested as a protein source, right? So in the cow, all of those bacteria, that's perfectly good protein. In the hindgut fermenter, all this fermentation takes place downstream, right? After the stomach and small intestine. So those millions of microorganisms that help to digest cellulose, they just end up in poop, right? All that potential protein is lost. The rabbit reclaims some of that protein by eating those cecotropes. That's part of why they eat cecotropes. They reclaim some of that of the bacteria mass, the protein. They also get, I think, it's some B vitamins. So I think of, you know how whales, certain like the blue whale eats krill. I think of bacteria as being like krill. You know, they're very small, but you add them together and it's able to feed a blue whale. That's kind of what the cow is like. All these bacteria, you add them up, it provides protein for the cow. So what is fermentation? So if you've ever had beer or yogurt or kimchi, you know what fermentation is kind of. What it is, it's a metabolic process in which some sort of an organism like bacteria or yeast are going to convert a carbohydrate like starch or sugar or cellulose into alcohol or an acid, right? So fermentation will turn it'll turn grains into beer. It'll turn grapes into wine. It'll turn that cabbage into, you know, this kind of, you know, vinegary kimchi. The or sauerkraut. Okay. It'll also produce from cellulose. It'll produce what are called volatile fatty acids. And this is just kind of showing you. Here we are in the rumen, this giant fermentation chamber, and in comes forages and in come grains and, you know, all these bacteria, you know, the microbial activity, they're going to break it down. And here's the thing, they make all this glucose. Yeah, I'm gonna repeat this a few times. All that glucose, the cow never sees it. All that glucose that they just freed up from these from the forages, they eat it. The bacteria eat it. They use it for energy. The cow never gets it. But the bacteria produce, I think it's even kind of a waste product for them. They produce these things called volatile fatty acids, and some of them are named acetic acid or butyric acid or propionic acid. Well, what are they? And they're kind of hard to explain. Volatile means that they vaporize easily, but that doesn't really help us to understand them. You know, are they a liquid? What are they? They're just these little small molecules that act as a fuel source. Well, here's how I think of them. Okay, and if this comparison helps, use it. Otherwise, ignore it. So I think of volatile fatty acids as being like alcohol. All right, alcohol is an energy source, right? Alcohol has calories, right? If you drink too much alcohol, you're going to gain weight. So it is kind of an energy source. It's produced by fermentation. Okay, they have that in common. They are not the same. All right, volatile fatty acids are not alcohol, but it helps. You know, it's not a carbohydrate. Alcohol is not exactly a carbohydrate. Alcohol is not a fat. It's alcohol. Well, That's why I use this comparison. Volatile fatty acids, they're not really a fat, but they're also not really a carbohydrate. Um, I guess they are kind of a fat, they're fatty acids. But anyway, they are what the cow is going to use to make glucose. So as I said, all the bacteria and the yeasts in the cow or in the horse or the rabbit, they eat up all that glucose. They don't release it from the cellulose and let Maddie or Honey or anybody have it. They just use most of it themselves. Um, in the horse, it's a little different because food has traveled through the stomach. But in the cow, the stomach never gets to see that sugar. Um, as we said, the bacteria and there are yeasts in the rumen too. They produce the volatile fatty acids that gets absorbed across the wall of the rumen or the cecum and large intestine in the horse. And where does it end up? Traveling through the liver, where the liver can turn them into glucose using this process of gluconeogenesis. Um, the let me just stay here for a moment. So what this means is if you like to drink milk, milk has lactose in it. Lactose is a kind of a sugar, but the cow she had to make all of that from scratch. It's not like she got to eat a candy bar and take that sugar and make lactose out of it. Um, this blows my mind. This is what I think is so amazing about the cow is all the blood sugar, well, heck, all the blood sugar in her body, right? None of that came from directly from what she ate. She had to make it from scratch. Think of that. If your blood sugar is a little low, you can eat a Snickers bar and you feel better. If she eats a Snickers bar, the bacteria destroy it. And she goes, I have to make my own glucose. I know. That's kind of crazy. And not just cows, all ruminants. And I know more about ruminants than I do about horses. It's probably very true in horses as well. But I just know they do have, there's if a horse if I feed Levi a Snickers bar, he will get to absorb it because it will go to his stomach. Um, don't I'm not planning on feeding Levi a Snickers bar. Okay, but anyway, that's it. That's where I wanted to end on this kind of crazy world of the cow. Again, understanding this will help you as you learn about the various large animal diseases next semester. And again, hopefully some of you will write about rumen acidosis and things this week and colic and things like that. So okay, that's it. Thank you very much. And I will give me maybe a day or so and I'll be able to figure out those cahoots. There's some there already. You're welcome to start looking at them. And I'll put links, but I might fiddle with them a little bit. Okay. Hope you're all doing well and take care.